All right, so I wanted to make a video on evolutionary classification. The information for this presentation came from CK12, which is an online textbook, and you can use this link to go there if you want to read more. So what are some ways that we classify living things? Take a moment, pause the video, think about it. Well, you might have thought about plants, animals, mammals, or insects, right? Well, let's talk about how scientists classify living things. Way back in the 300 BC, we had a guy named Aristotle who classified living things into plants and animals. That was a very good start, but we need to get a little bit more detailed. And it wasn't until the 1700s that we really got a really scientific classification system. And it was a guy named Carolus Linnaeus who came up with this hierarchical system. You might have heard of kingdom, phylum, order, class, genus, species. That is Linnaeus who came up with that system. We still use it today, but it's not really the focus of, I guess, like a freshman biology class. We don't make you memorize that kind of thing. But it is used for scientific names of animals and plants. So let's go on. Linnaeus helped us to create this diagram called a cladogram. Basically, it's a family tree, except for it uses physical traits to approximate or estimate relatedness among organisms. Examples of physical traits could be hair, a spine, vertebrae, or limbs. As you can see here in the picture, carnivorous teeth or horns are also more examples of traits that are used for classification. So eventually, Charles Darwin came around and he came up with this amazing idea of evolution. And then scientists were like, hey, let's actually organize living things based on their evolutionary relationships. So that's where phylogeny comes in, and that was used to show evolutionary relationships. A phylogenetic tree is the same thing as a cladogram, except for sometimes some scientists reserve this word specifically for a evolutionary tree that was made off of genetic information. Okay, so that's what that is. What is a recent common ancestor? Okay, so over here to the right, we have a phylogenetic tree, and there's this circle. That's a node. A node is a recent common ancestor. So if you have species 1 and species 2, you go backwards in time down the tree, the node is where they diverged, right, into different species. So this is, the node is their recent common ancestor. What is a clade? Well, a clade is a common ancestor and all of the descendants. So you'll notice here in this green box that the common ancestor of all of those organisms up top is circled, all right? If you go down here, the reason these guys are not clades is because they do not include all of the common ancestors and also all of the descendants. So the orange box is missing one of the descendants, which is why it's not a clade. The red box is not a clade because it's missing the common ancestor. So let's build a cladogram. Obviously, cladograms are made based on physical similarities. Usually you're going to start off with some kind of chart like this one, where you have to mark whether or not the organism has the trait. So a frog has a vertebrae, but it doesn't have 2 limbs. It doesn't have mammary glands. Kangaroo has a vertebrae and 2 limbs and mammary glands, and a human has all of those things. So then what you do is you draw your line and you add little lines for the traits and bigger lines for the animals. And you add everything on. And what it really shows is it shows how these things developed. Okay, so first organisms had vertebrae. All of these guys have vertebrae because it's lower on the cladogram. And then eventually the trait of having 2 pairs of limbs evolved. Right? And we have frogs that have those. And then mammary glands evolved. All right, so notice how this is an arrow. That's because it's showing evolutionary time. It's showing a progression of time and the evolution of traits. Okay. Really fun website is this creately.com site. We're going to actually use this in class to make a cladogram online.